Hello everyone, and welcome to our week 5 class. I hope that you're doing well and enjoying your week so far. Now the agenda for today is to go over last week's quizzes, followed by the week 5 material. And in the previous week, I talked about functions, and today I will be continuing this discussion with more advanced topics in using functions. So I will talk about variable arguments in functions, I will talk about lambda functions, I will talk about higher order functions, recursive functions, as well as function decorators. As for the assignments that are due this week, we have 2 assignments, one which will be all about functions. As for the second assignment, it will be the start of our final project. So without further ado, let's get started. Alright, so in a previous video, we talked about the basics of functions, and today I wanted to discuss some more advanced topics. Okay, now just a quick recap in using arguments with functions. We can have positional arguments and we can have keyword arguments. The positional arguments will depend on the position location or the order of the argument, while keyword arguments will not care about the order or the location of the argument. Instead, it will use the key equals value syntax. However, both these type arguments require that you know the number of arguments needed for the function. But what happens if you don't know? I mean, what if you want to build a function that can take a variable number of arguments? That's where the star args and star quargs come into play. So in Python, star args and star quargs are special syntax used in function definitions to allow a function to accept a variable number of arguments. Now these notations are commonly used when you want to create more flexible and generic functions that can handle different numbers of arguments. Star args allows you to pass a variable number of non-keyword arguments to a function, and it collects these arguments into a tuple. Here's a simple code example. So in this example, the add_numbers function can take any number of arguments, and it adds them together using a loop. So I create a function called addNumbers, and in the parameter area, I type star args. Now this indicates that I can accept a varying number of arguments. Then I have indented code in the body of the function, which runs a few statements to loop through the arguments and adds them to each other. And so in my first function call, I call the addNumbers function, and it passes 5 arguments, which are the integers 1 through 5. So this function call demonstrates that this function can accept 5 arguments. Then I have another function call, but this time I only pass 2 arguments, and the numbers are 10 and 20. So now the addNumbers function will still work because I'm using the star args notation. Now by the way, I don't have to use the word args in particular. So I could have used star followed by any word that I want. And I'll show you this when I go through my code examples later. But it has become customary to name the variable arguments as star args. Now, we also learned before that there are 2 types of function arguments. One is positional and one is keyword. Positional is when the position of the argument matters, while in keyword argument, we specify the value of the argument when we pass it. The previous slide showed us the variable positional arguments, and now this slide shows the variable keyword arguments, which uses the star quargs notation. Now this star quargs allows you to pass a variable number of keyword arguments, like key value pairs, to a function, and it collects these arguments into a dictionary. So here's a code example. In this code example, the printPersonInfo function can accept any number of keyword arguments, and it prints them out as key value pairs. So when I call this function, I pass it 3 key value pairs, name is equal to Alice, age is equal to 30, and city is equal to Wonderland. And when I run this, I get a loop of the key values from this dictionary. I could also have passed any number of key value pairs, and the function would have processed them successfully. Now, you can also use star args and star quargs together in a function definition, but keep in mind that star args must appear before star quargs. So we can mix and match them, but for this mix and match to work, you must organize the star args before the star quargs. So in this example, we start off with arg1 and arg2, which are just regular position arguments. Then we have star args, which collects additional position arguments of an unknown count. Then we have quarg1, which is a default keyword argument. And finally, we have star star kwargs, which collects extra keyword arguments, also of an unknown number of items. Now, in the function call, I have arguments with values 1, 2, 3, 4. I also have kwarg1, which is set equal to custom. I have name, which is set equal to Alice, and age, which is set equal to 30. So this means that arguments 1 and 2 will go to the parameters arg1 and arg2. Then arguments 3 and 4 will be used by star args. Then argument kwarg1 equals to custom will be for parameter kwarg1. But instead of having the default value, it will have custom. Then the rest of the kwarg arguments, like name equals Alice and age equals 30, will be used by the star star kwargs parameter. So as you can see, using star args and star star kwargs can make your functions more flexible and versatile, allowing you to handle a wide range of input arguments. Okay, so this code example basically is going to show us how we deal with star args as well as star star kwargs. So this very first example is just a function called test1, and it takes star args. Now this is going to tell me that I don't know how many arguments I'm going to be getting, but I will accept an unknown number of arguments. Once I get them, I'm just going to print them out. So it's a very simple example to illustrate how star args work. Then in my function call, I'm going to call the test1 function. I'm going to pass it one argument and then a second argument. So let's run this and see what we get back. Do F5, and I get back a tuple with all my arguments. Okay, so the function worked, it didn't error out. Now let's try to add a third argument. I'll just call it 3, and let's run it again. And again it works, it doesn't error out. So this is just a quick simple proof that star args, this allows us to take any unknown number of arguments and process them accordingly. And like I said before in my presentation, you don't have to use the word arg. So I can change this to any word. I can say wording, which doesn't make any sense, and then change wording here, and then if I run this, it still runs correctly. Okay, it doesn't error out. So again, you don't have to stick to star args, but it's been customary that we use args as the keyword. Alright, now this has been a simple example. It's not really helpful, so let's see how we can use it in a more helpful option. Let's bring back this in. Alright, so this is a function called add numbers. Again, takes star args, and there's some code here. And down here, I'm calling the add numbers function. One time I'm passing it 3 numbers, and one time I'm passing it 2 numbers. So all what this function is doing really is that it's taking any arguments that I'm passing, and it just adds them together, and then returns the result. Okay, so this is a good example where you want to have a add numbers function, but you just don't know, or you could sometimes going to get 2 numbers, you're going to get 5 numbers, you can get 1,000 numbers. So the star args solves this problem for us. I'm going to call this function with unknown arguments. I'm going to accept any number of arguments. I'm going to process them accordingly. So I'm going to call this function with 3 arguments. I'm going to store the value in a variable called sum1. Then I'm going to call it again with 2 arguments, and then assign the value to sum2. Then I'm going to print them out using this print statement. So let's run this and see how it goes. And there we go. Push this to the right. Sum1 is 6, which is 1 plus 2 plus 3, that is 6. And sum2 is 30, which is 10 plus 20. And this is my print statement correctly outputted. So this example does clarify that star args works for positional arguments. Now what happens if we want to see keyword arguments and we don't know how many we have? So this example down here does exactly that. We have again test1 function, and instead of star args we have star star kwargs, okay, keyword arguments, and then we're going to print them out just like we did before. But do remember that when we printed out the star args, they came back as tuples. When we print out the kwargs, they come back as dictionary, because we have a key and value item. Okay, so again, I'm going to be calling test1 function. I'm going to pass it one item with a key value pair, second item, third item, fourth item, fifth item. Okay, so if I run this, it should run correctly. And again, you can see here that I got back a dictionary of items with key value pairs, key value, and so on. All right, but again, to see how the star quarks works, I can basically remove as many items as I want, and it's still going to run and process it. And there we go. So that's the beauty of having star args and star quarks. Now we are not restricted to using star args on its own or star quarks on its own. We can technically combine both of them together. So this example down here does exactly that. All right, so I have a function called example function, and it's taking a slew of parameters. One is arg1, arg2, star args, quarg1, which is equal to default, and then star quarks. So arg1 and arg2 are positional arguments. Star args are an unknown number of positional arguments. Then we have a keyword argument with a string value called default, and following that we have star quargs, which basically tells us that we can have, again, an unknown number of keyword arguments. And then in the body of the function, I just print out every single item. I print out what arg1 is, what arg2 is, what args is, which is the star args, and then quarg1, and then quargs, which is the star quargs. In my function call, again, I call the function by its name, and I'm going to pass the first position argument, which is 1. So 1 is going to be arg1, 2 is going to be arg2, and then 3 and 4 are going to be star args, and then quarg1, I have it equal to test. Now, I defined it here as quarg1 equals to default. Now, why do I do that? Well, if quarg1 is not passed in my function call, then it's going to default to a string value called default. All right, but if I do specify it, then test would override this value here. Okay, so quarg1 is going to be equal to test instead of default. Then for my star quargs, which could be an unknown number of keyword arguments, I'm going to have name is going to equal to Alice. I'm going to have age equals to 30. I'm going to have city equal to Wonderland. So if I run this now, and let's push this to the right, a little more to the right. Okay, so my argument 1 is 1, which is correct. So 1 is this because it's positional. And 2 is 2, yep. And then args, which is the star args, is a tuple of 3 and 4. So 3 and 4 taking star args. And then for quarg1, it's test because that's my first keyword argument, and it's not default, it's test because test overrides default. And then for my star quargs, I have a dictionary of all my 3 key value pairs. And just to show you that if I don't specify a quarg1 variable here, and I run this, the quarg1 takes the default value, which is specified here in the definition. Now, something else you need to be aware of is that the order of which comes first, the star args or the star quargs. And if I start by including my quarg, so I do quarg1 equals to test. So now I have my quarg, and then I have my args. So my keyword arguments are preceding the position arguments. If I run this now, I get this error. Positional argument follows keyword argument. Okay, so that's not allowed. So you always have to pay attention to that. You first list your position arguments, and then you follow them by the keyword arguments. Okay. In Python, a lambda function is a small anonymous function that is defined using the lambda keyword. Lambda functions are known as anonymous functions because they don't have a name like regular functions defined using the def keyword. And so lambda functions are typically used when you need a simple function for a short period and don't want to go through the process of defining a full-fledged function. Now the general syntax of a lambda function is as follows. We start with the word lambda, which is a reserved word in Python, followed by arguments, which are optional, followed by a colon, then some sort of an expression. And this all goes on one single line as you see here. So lambda is the keyword used to define a lambda function. Arguments are the input parameters for the lambda function, just like the arguments in a regular function. An expression, this is a single expression that is evaluated and returned as the result of the lambda function. And in this slide, we have an example of how to use a lambda function. So in this example, we defined a regular function called add that takes two arguments, x and y, and returns their sum. We then define an equivalent lambda function called add underscore lambda that does the same exact thing. We start with the word lambda, then pass the needed arguments, which are x and y, then we have a colon, then the expression, which in this case is adding the two arguments together. And all this is assigned to a variable called add lambda. And then we see that we call both the add function and the add lambda function the same exact way. Then we print out the results, which both will yield an output of 5. So lambda functions are often used in situations where you need a short function for purposes like sorting or filtering, and I'll show you a code example later using the sorted function in Python. A recursive function in Python is a function that calls itself to solve a problem or perform a specific task. Recursive functions are often used in situations where a problem can be divided into smaller, similar subproblems, and the function can solve these subproblems by calling itself with modified arguments. Each recursive call should move closer to a base case, which is a condition where the function does not call itself and instead returns a result directly. Now please be careful here, because without a proper base case, a cursive function can lead to infinite recursion and cause a Stack Overflow error. Alright, so let's look at an example of a recursion function to calculate the factorial of a number. And in this example, the factorial function calculates the factorial of number n. If you remember from your high school math days, the factorial of a number is when you take a number and multiply it with each number less than that number until you reach 1. So if I say what is 3 factorial, then it would mean 3 times 2 times 1, which would give us 6. So in the code example here, it uses a base case where if n is equal to 0, it returns 1, because the factorial of 0 is defined to be 1. And in the recursive case, it calls itself with the argument n minus 1 and multiplies the result by n. Now this continues until the base case is reached, at which point the values are multiplied together as the function calls unwind. So here's a step-by-step breakdown of the factorial 5 function call. Factorial 5 calls factorial 4. Factorial 4 calls factorial 3. Factorial 3 calls factorial 2. Factorial 2 calls factorial 1. Factorial 1 calls factorial 0. And at this point, the base case is reached and factorial 0 returns 1. So the recursion then unwinds and the values are multiplied as 1 times 2 times 3 times 4 times 5. So we can say that recursion can be a powerful tool for solving problems, especially when the problem can be naturally divided into smaller subproblems. But again, it's important to ensure that there is a base case and that the recursive calls lead to the base case to avoid infinite recursion. Function decorators. Now, as the name implies, we take an existing function and decorate it, meaning add small things to it or modify it slightly. So a decorator in Python is like a wrapper for a function. It's a way to add extra behavior to a function without changing the function's code. You can think of decorators as functions that take another function and return a modified version of it. Here's a straightforward example. In this example, my underscore decorator is a decorator. It takes a function, func, and returns a new function, wrapper, which adds some behavior before and after calling the original function. So here we see a simple function called say underscore hello that just prints the word hello with an exclamation mark. Then, when we use the @my_decorator just above the say hello function definition, which is like saying apply the my_decorator to the say_hello function. So when we call say hello, it's actually the wrapper function that gets executed, and it surrounds the original say hello function with extra behavior. And please be aware of the @ sign, as that is what we use to know that this is a function decorator. Now, if this is all too confusing right now, please don't worry, as I will show you a code example in just a few moments. So decorators are often used to keep code clean and modular, especially when you want to apply the same kind of behavior to multiple functions. They're like a way to wrap functions with additional functionality without cluttering the original functions code. In Python, higher order functions are functions that can take one or more functions as arguments or return a function as the result. Essentially, they treat functions with priority, allowing you to work with them just like any other data type, such as integers or strings. Now, this concept is closely related to functional programming and is a powerful tool for building more flexible and modular code. Now, here are two common higher order functions. I'll start first with the map function. Map in Python is a function that works as an iterator to return a result after applying a function to every item of an iterable, like a tuple or a list. It is used when you want to apply a single transformation function to all the iterable elements. And as you might have guessed it, the iterable and function are passed as arguments to the map function in Python. So if you look at this example, I have a function called square that takes one parameter, and the indented code just takes this parameter value and multiplies it by itself. So we are essentially squaring the value. Then right after this function, we have a list of numbers, 1 through 5. Then I call the map function and pass it the expected function, as well as the data. The function is the square function, and the data is the list of numbers. So this square function will run iteratively on each item in my list. Then I convert this data to a list, because if I don't, it will just return a map object. Then I assign it to a variable called squared numbers. Then I'll just print it out, which will output each number in my numbers list as a squared number. So 1 squared will be 1, 2 squared will output 4, and so on. So this is just one example of showing you a higher order function where one function uses another function. And again, I'll show you this in a code example soon. And here's another higher order function, filter. Filter is a built-in function in Python. Now the filter function can be applied to an iterable, such as a list or a dictionary, and create a new iterator. This new iterator can filter out certain specific elements based on the condition that you provide. Now the example in front of us here starts off with a function by the name of is_even and takes one parameter. We then take this parameter value and do a mod2 equals to 0 check and return it. If something has a mod2 equals to 0, this means that it doesn't have any remainder, so it's an even number, because any number that is divisible by 2 with no remainder is an even number. Then we move on to the next lines of code, and very similar to the map function, we use the filter function to filter out just the even numbers from an existing list of numbers. The filter function takes the isEven function as the first argument, and the numbers list as the second argument. I also convert the output to a list, since the filter object is not helpful on its own. Then I assign it to a variable called even numbers, and then print it out. So these higher order functions are powerful tools for simplifying and clarifying code, especially when you need to perform operations on collections of data. They encourage a more functional and declarative style of programming, which can lead to more concise and readable code. This code example will show us function decorators. So in the second half below here, I have a very simple function called sayHello. All it does is just prints the word hello followed by an exclamation mark. And then I have the function call here. So when I run this, I'll just get the word hello, exclamation mark. Now if I want to modify the behavior of this function without actually changing the code of this function, that's where the decorator comes in. So up here I have a function decorator that takes the argument func, which is the original function, which is this guy here. And then inside the function, I have a wrapper function, and then that has the code which does something. So the code basically says just a print statement, and then I call the function, which basically is this function here, and then I have another print statement. So this example here of indented code, just going to print something is happening before the original function is called. Again, the original function is the say hello function, which I call it using the func keyword, and then I call it here. And then I call the original function, which again is the say hello function, and then I follow it by another print statement that says something is happening after the original function is called. So again, I'm modifying the behavior of this function without actually modifying the code of this function. Another key important item is this line here. To decorate this function, I call the @ followed by the name of the decorator function, which is my_decorator. Okay, so here you define the decorator function and then how you want it to behave. And then just before the original function, you add this line of @ followed by the name of the decorator function. So now when I call this say hello, let's see what happens. So I get my print statement before, then I get the original function, and I get the print statement after. So the decorator function is a way to allow us to modify the existing behavior of an existing function without actually changing the code of the original function. This code example talks about higher order functions, and these are a type of functions that can take a function as an argument. So the first example I have here is I have a simple function, I called it square, that takes one parameter x, and it just returns the x parameter times itself. Very straightforward. Then down here I have a list called numbers that has 1, 2, 3, 4, 5 as elements. And then down here I have a variable called squared numbers, which I assign it to, I'll come to list in a moment, but there is a function called map. That's a built-in function. Again, it's a higher order function in Python that takes a function as an argument and takes data as a second argument. So the map function is going to take square, which is this function here, as an argument, and it's going to map every item in my data. So every item in my data, which is numbers, is 1, 2, 3, 4, 5. It's going to map those numbers to the square function and return the value of each item being squared. And then I convert the output to a list, because if I don't, I'm actually just going to get a map object, and I'll show you that in just a moment. So this list is going to be assigned to the squared numbers variable. Then I'm going to print it out, which I should get 1, 4, 9, 16, 25. Why is that? Well, because the map function took each element in numbers and applied it to the square function, which is 1 squared, or 1 is going to be x, so x times x, 1 times 1 is going to be 1. 2 is going to be x, so 2 times 2 is going to be 4. 3 is going to be x, so 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So this should be the output, and it should be in a list format. So let's run this and see what happens. That's exactly what I get. Alright, I get a list of my map function, which took the arguments, the square function, as well as the data, which is numbers. Now, if I did not convert this to list, so I'll remove the list function here, and I run this, I'm just going to get an object of my map function. There we go, map object, so it doesn't help me. So if I convert this to list, then I would get back a list, which is more helpful. Alright, let's comment this out again. And let's bring this in. So just like the map function here, there's also another built-in high order function called filter. Now filter is going to take basically a list, and it's going to filter it based on some sort of a function. So I have a simple function here that's called is_even, takes one parameter, and then it's going to return the modulus of 2 if it's equal to 0. Basically, if the number is divisible by 2 with no remainder, then it's going to return that number, because this is what is considered an even number. So again, I have a list of numbers. Some are odd, some are even. And then I'm going to filter only on the even numbers. So the filter function, which is a built-in function, which is a high order function in Python, is going to take a function as an argument, and it's going to take data, which is numbers, which again is this list here, and it's going to filter out the numbers that are only even. So I should get back 2, 4, 6, 8, 10. So let's run this and see what we get back. And there we go. The filter higher order function took a function as an argument and applied it to the numbers list, which is an iterable, and printed out just the even numbers because it filtered the list using the isEven function. In this code example, we are talking about lambda functions. So a lambda function allows us to create an anonymous, very short, very quick function that can do the same thing as other full-fledged functions, but in a more streamlined fashion. So up here, I have a very simple, traditional, regular function called add. It takes two parameters, x and y, and then returns the sum of x and y. And right below it, I have the equivalent of doing the same exact thing. So to code this using lambda, I basically use the lambda keyword followed by the arguments that I want to use, or parameters that I want to use, which again x, y, just like I have up here, followed by a colon, then followed by the expression of what I want to do as the body of my code. So just like I'm returning x plus y here, I'm also going to be returning x plus y. So all of this is going to return some sort of a value. I'm going to store this returned value in a variable called add lambda. And to call a lambda function is the same exact way as I call a regular function, by its name. So here I have a function call, and I'm passing the values 2 and 3. And now I have another function call, this time to the lambda function, which is again called add underscore lambda, and I'm passing also 2 and 3. And both of them are going to be printed out, the results 1 and 2. And so if I run this now, I get exactly the same output, 5 and 5. So we were basically able to use the lambda function, which is a more streamlined way of creating functions as compared to this traditional way, and still get the same exact result, which is 5 and 5. Now I can also use the lambda function with one of the built-in functions in Python, which is sorted. So the sorted function allows you to sort data in an iterable, like a list, for example, or a tuple. And by default, if the data is numerical, then it's going to be ascending from small to big. And if it's a literal type, like a string, then it's going to be sorted by default in alphabetical order. So the sorted method, again, is a built-in function in Python that takes data as a required argument, and then the key argument is optional. But the key argument allows you to configure how you want the data to be sorted. And one way to do that is to pass it a function that handles that piece of information. So sorted takes one required argument, which is the actual data. In our case, it's a list of tuples. And we're going to sort the data using a key, which is a lambda function that basically says, take the argument x, which this will be x, this will be x, this will be x, and sort it according to the second element of each tuple. And this newly sorted data is going to be assigned to a new variable called sorted data that I'm going to print it out. So let's run this and see what happens. So based on the second element, which is x index location 1, remember index are 0 based, so index 1 means the second element. So I'm not ordering by the first element of each number, I'm ordering by the second element of each number. So 4, then 5, that's correct, then 10, which is correct. So if I basically just take this data here and not specify a key which can configure how I want the data to be sorted and run this, I'm going to get the default, which is by the first element. So 1, and then 2, and then 3. But I want to have more control and basically sort this using the second argument. So the way to do it is just like I had it here. I use the key argument and then set it equal to some sort of a function, and my function can be used here as a lambda because it's more streamlined, and it takes one argument, and that argument is just return the second. So if I want to do the first one, you basically do 0 for my index. And if I run this now it's organized, or it's sorted by the first element. So 1, and then 2, and then 3. So again, lambda is a very powerful, a very flexible way to write functions that are anonymous, that are just one-liners, that can do a lot for us. Here is just one example, and here is another example that you can use it as part of the sorted built-in function in Python. In this code example, we have a case of a recursive function. So recursive functions are, just like the name implies, they are functions that call themselves over and over and over again. And a great way to demonstrate this is using the factorial in math. Now, if you remember again from high school days or middle school days or college days, we learned that, for example, factorial 3 is nothing more than 3 times 2 times 1. If we do factorial 10, then it's 10 times 9 times 8 times 7 times 6, all the way down to 1. So to do this in code, we basically created a factorial function called a factorial, and it takes one parameter, which is n. Now, part of the recursive functions is you need to have some sort of a base case, because if you don't have a base case, then it's technically going to become or turn into an infinite loop, where it just keeps going and going and going and going and going and going, because it doesn't know what the base case is. So our base case is like our stop sign. Once we reach that stop sign, then we're done recalling the function over and over and over again. So here I have a function called factorial, takes an n as a parameter. Now, this is my base case. If n is equal to 0, then return 1, and basically that exits the recursive calling. It doesn't call itself anymore. But in the else behavior, I have return n times factorial n minus 1. So factorial n minus 1 is basically going to call itself again. So the function is called factorial. This is its base case. But when we have not reached the base case, I'm usually down here. And then what happens here is I take n, whatever n is, then I'm going to call factorial again, this time using n minus 1. Okay, because that's how factorial works. You take a number, then you multiply it by the number less than it by 1. Then multiply it again by this number less by 1. Then that number, multiply it again, less by 1. Okay, so every time the factorial gets called here, it goes all the way up here and runs the function again. Comes down here, sees another recursive function call, then goes back here and calls itself. Comes down here, calls itself. Comes down here, calls itself, until n is equal to 0, which eventually it will be, because we are subtracting 1 every time we come to this else statement. So for example, factorial 5 basically says, okay, let's call factorial. 5 is going to be n. So n, if n is equal to 0, no it's not, then go to the else. So return n, which is 5, times factorial 5 minus 1. So factorial 5 minus 1 would be factorial 4. Now if n equals to 0, no it's not, so go to the else. And return 4 times factorial 4 minus 1, which would be 3. So let's call factorial 3, which is up here again. Factorial 3, if n equals to 0, no, because it's equals to 3. Then we go to the else. Then we say 3 times factorial 3 minus 1, which is 2. So factorial 2 goes up here because it calls it again. Factorial 2 is not n equals to 0, so go to else. So we return 2 times factorial 2 minus 1, which is 1. So we call up here factorial 1. Now if n equals to 0, no it's not yet, so we go to the else. Return 1 times factorial 1 minus 1, which would be 0. So factorial 0, if n equals to 0, yes it is, then return 1, and this would be our base case, which is factorial 0, which in math is 1. So all this is going to get returned into, or assigned into, a variable called result. Then we're going to print it out, and eventually we're going to get 120, because 5 factorial is 5 minus 5 minus 1, which is 4, times 4 minus 1, which is 3, times 3 minus 1, which is 2, times 2 minus 1, which is 1. And this gives you 120. So if we run this code, that's exactly what I get. So this is an example of how a recursive function can call itself over and over and over again, but just please make sure that you have a base case so you can eventually reach the end and exit the recursive function. So the assignment for this week is divided up into two assignments. One is the Python part, and then we have the R part as well. For the Python part, we have two parts. We have the salary function and the economic order quantity function. So we basically need to create two functions. The salary function is going to ask us to prompt the user to enter some sort of a salary number, and based on the input, then we're either going to say if it's higher or lower or equal to the salary that we're comparing to. So it's a pretty much straightforward salary function assignment. The part 2, which is economic order quantity function, it's a little bit more involved. We have to use the math library, and we're going to be doing some calculations. And the good thing is all the details are provided to us here. We just need to create a function that performs these calculations for us. And everything is laid out in great details here. Now for this function, we don't have to prompt the user, so we're not going to be using the input function. We're going to hard code the values for all that will be used in our different calculations. And please don't forget that once you create the Python assignment, you need to create a short voiceover video. Now, if for whatever reason you have technical issues creating a video, then please just create a Word document and write up all the explanation that goes with this assignment. So I will go over the Python part of the assignment, but then please don't forget there's a second part of the assignment, which is the R code. And the R code part is just using the econ order Q function again, but this time writing it in the R language. Okay, so if you do it in Python, which I will show you, then please do the same thing using R. And then also don't forget to create a short voiceover video or some sort of a Word document explaining the flow of your code. Okay, here's my version of the code for the Python assignment. Again, it's two parts. Part 1 is the salary function, and then part 2 is going to be the econ order Q function. So let's start with the very top part first. Always don't forget to comment your code, and basically when you have a function, it's always to include a 1 or 2 line comment that basically explains what this function does, because having a comment will definitely be easier for anyone reviewing your code, including yourself. So instead of having to go through all the code and understand what it does, a quick 1 or 2 line comment just before the function starts will go a long way. So basically here I just wrote define function to accept salary parameter and print a statement according to the input value. So this is very easy to understand, and I don't have to go line by line to kind of decipher what this function does. So I'm going to start with the def keyword to define my function. I call the function check_salary, and it takes one parameter, which is salary. Then I have a if else or if else statement. So basically if salary is less than 8,000, or sorry, if salary is less than 80,000, I'm going to print salary is lower than the average. If salary is greater than 80,000, then print salary is higher than the average. Else print salary is the same as the average. So there are 3 scenarios here. When you're comparing numbers, it's either going to be less than, or it's going to be bigger than, or it's going to be equal to. So this is where the if else logic fits in. And now this is just defining the function. Function is not going to get called or not going to be run until some code calls that function by name. And this is where this happens. I'm creating an input function and passing it the prompt to enter the salary. And so this is what the user is going to be prompted with. And whenever the user enters, it's by default the input value is a string data type. Now since I'm going to be working with numbers and I need to do comparison, then I need to convert the string input value to an int, so it becomes an integer. And that will be assigned, put a space here, that will be assigned to a variable called actual salary. And then I'm going to use that variable as an argument in my check salary function call. Okay, so this is the name of the function, and so technically it's a function call here. I'm passing the expected argument, so here it's expecting 1 parameter, and I'm passing in 1 argument, so these have to match. So when I say check salary and then pass the actual salary that the user inputted here, then it's going to go up here, and then salary is going to be the value of whatever gets passed here in the function call, and then this logic is going to run, and then it's going to return the value back to the function call. Alright, so that's the first part of the assignment, check salary. Then we come down to part 2. First thing we have to do is import the math library, because we will be using one of the math methods, which is square root. And again, start by defining a comment, but again, this is a very simple comment define function using the math library. Again, you could make your comment as detailed as possible. The more, the better. The point is, if you write a comment, it should explain everything that happens here so that I don't have to go through line by line and understand what this function is doing. So I'm going to define a function, again, per the instructions, called econ order q, and it needs to take 5 parameters: demand, order cost, holding cost, leading time, work days. And again, these are all defined in the assignment instructions. The economic order quantity is going to be the square root, so I'm going to use the math library and then the square root method of the math library, and the formula is 2 times demand times order cost, all divided by holding cost. Again, I didn't make this up, this is all part of the assignment instructions. Then annual order cost is another variable we have to define, and basically the formula is demand divided by economic order quantity multiplied by order cost. Now the assignment is going to also say to round that value to the 2 decimal spots. Okay. Annual holding cost is another value we have to calculate for. Again, this is EOQ, which is economic order quantity divided by 2 multiplied holding cost, and again round it 2 decimal spots. The ROP, or the reorder point, is equal to demand divided by work days, all multiplied by lead time. And this time we don't round to the 2 decimal points, we round to the 4 decimal points. So again, wrap all this up in a round function, pass it the value that you want to round, and then how many decimal points you want to round it to. And the EOQ, again, the economic order quantity, again, round it to the 4 decimal spaces as well. And then we're not going to return just one thing, we're going to return all these values: EOQ, annual order cost, annual holding cost, and the ROP. Now, for this function, the instructions tells us we're not going to prompt users for values, we're just going to hard code them here. So for the D, which is the demand, it's going to be equal to 4,000. And the cost per order is going to be 40. The holding cost per unit per year is going to be 0.1. And the supplier lead time is 4, and the number of work days per year is 250. Okay, so these are hard-coded, meaning that we're not going to be prompted and we don't have to enter them, we're just hard-coding them here. And then at the very bottom, we're just going to call that econ order q function, pass it all these different positional arguments. Again, make sure that you have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. Okay, so 5 positional arguments for 5 parameters, so that's correct. And then we're just going to, once we call this function and pass these arguments, we're going to get the results back, and we're going to get back these 4 things. And then we're going to create a lot of print statements, each one for the different return value: the EOQ, annual order cost, annual holding cost, and the reorder point. And here I'm just using the formatting, the F format, to format my string, and in the braces is where I have the values returned. And again, these are basically going to come back as a list, and again, I'm using index notation. So index, this value, this list, index 0 is going to return the first item, which will be this one, and then the list index 1 is going to return the second item, and then index 2 is going to return the third item, and then index 3 is going to return the fourth item. Okay, so let's run all this and see what we get back. Okay, so enter salary. This is for the first part of the assignment, which is this guy here, inputting enter salary. So again, you always have to test the different scenarios. So let's enter first when the salary is less than 80,000. So let's do 9. Just 9 is less than 80,000. Hit enter. So the salary is lower than average, which is correct. Okay. And then I also have the second part of the assignment down here, and this is what we got back. So again, the EOQ, economic order quantity, is so and so, and you can see here that it's rounded to 4 digits or 4 decimal points. And then the annual order cost is so and so, annual holding cost is so and so, and the reorder point is so and so. Okay, so it looks like also the second part of the assignment worked fine. Now let's test now when the salary is greater than 80,000. So let's run this, and let's make it 90,000. Salary is higher than average, correct. And then let's run it one more time and set it equal to 80,000 exactly. Salary is the same as the average. Okay, so everything looks to be working correctly. Both part 1 and part 2 of the assignment is correct. Again, this is the Python part. Please also don't forget to create a video to explain the code. And also don't forget to do the second part of the assignment, which is the R code, which has to do with the economic order quantity function. So I hope this was helpful. Please let me know if you have any questions, and I'll be seeing you in class. Take care, and bye for now.